All right, now we're doing 7Q minimum perimeter of a rectangle. This is by Quinto, and 92% of people like it. A rectangle can be defined by two factors, height and width. Its area can be defined as the multiplication of the two, height times width. Its perimeter is the sum of its four edges, 2 times height plus 2 times width. It's possible to create rectangles of the same area but different perimeters. For example, the given area of 45, with the given area of 45, the possible heights, widths, and resultant perimeters would be these. Note that 6 times 7.5 has an area of 45 too, but it's discarded because it's not an integral. Its width is non-integral. Right. The task is to write a function that, given an area of a positive integer, returns the smallest perimeter possible of a rectangle with integral sides, lengths. All right. So basically, we got to get an area and then figure out what the lowest possible perimeter is, as long as it has like integrals for the sides. All right. Excuse me, integers for the sides, I should say. All right, so basically what we're going to have to do, because the smallest, no matter what, for a square, for a, whatever you call those, parallelogram? I don't know. Anyway, for a square, for a rectangle or whatever, it's going to be the square. Like the square root of that is going to be the lowest, no matter what. So all we have to do is do a for loop to find whatever the lowest combination is. Let me show you what I'm talking about. It's hard to explain. It's hard for me to explain, at least. So we're going to do a for loop to start off with. And inside this for loop, we're going to say, we're going to let I equal math.square root, okay? So math.square root function returns the square root of a number, basically. So we're going to say math.square root area. But see, the thing is, we want this to be an integer, because right now, when it's 45, let's do square root of 45. Let's go square root calculator. All right, so let's put square root 45 equals, no, square root 45 equals 6. So we want to get, we just want to see the 6 because we don't care about this 0.7 whatever. All right, so to do that, we're going to use this bitwise OR operator, and the bitwise OR operator returns a 1 in each bit position, which the corresponding bits of either or both operands are 1s. But that doesn't matter to us. What matters is this little trick that happens when you put 0 in this B place. So let's put 5.9 whatever. It doesn't matter. And then see what happens when we do bitwise or 0. And look at it, just gives us the integer right there. So that's what we're going to do here. We're going to say this bitwise or 0. All right. And when I equals this, as long as I is greater than 0, we're going to say I minus minus. All right. That way we're going to go down from the 6. And let me show you what we're going to do. All right. We're going to say if area remainder operator I equals 0. So basically, if let's say it's 6, clearly that's not going to work. Let's say it's 45 divided by 5, right? That's going to be equal 9, remainder 0, right? So 5 will be our I. So what we're going to do is we're going to say return 2 times, and then we're going to say I plus area divided by I. So it's going to be 5 plus area divided by 5. So 5 plus 9 is 14. Times 2 is 28. And let's see. 28. Ah, there it is right there. So let's see if this works. Test it out. All right, there we go. Attempt it. All right, submit it. And very much like this one, it looks pretty much exactly like Rachel Eckenrod's answer. Let's go to my solution. Best practice in my opinion. Very much like this one, and we'll see you next time.